Thanks so much for coming back. Hopefully you guys had some great conversation and food during lunch. For the afternoon session, I'm really excited to introduce our afternoon session moderator, Elizabeth Goldschmidt, Assistant Professor of Physics at UIUC.
All right, thanks, Kate. So we have a panel coming up, and our panel is going to be moderated by Alex Keesling. Alex is the CEO of QuEra Computing, one of the pioneers in neutral atom quantum computing. And Alex himself is one of the pioneers of neutral atom quantum computing, having done his PhD at Harvard under the supervision of Misha Lukin. And so I'm going to turn it over to him to introduce our panelists from our many different quantum startup companies.
Thanks, everyone. Thank you very much to the organizers for the opportunity that we all have to be here. I guess I have the easy job here of asking questions and letting our panelists answer. We're going to start with introductions from the panelists. I'll let them tell you about themselves and what they're working on. And we'll start with Mert Esencan. He is the founder of Icosa Computing. So Mert, please take it away. And I believe you have some slides even, right? Or if not, that's...
I think I do, but I don't have a clicker.
Yeah, hi everyone. I'm Mert, founder of Icosa Computing. We're a software startup out of New York City. And we build discrete variable optimizers for finance and AI using quantum physics. So before I tell you what that means, this is a team. We're physicists and computer scientists. We love solving difficult problems, as probably many people here are. My education was in fact, computer science and physics. I worked in the industry for a bit before I started this company. I was at Fidelity and QuEra, so Fidelity Center for Applied Technology as a great quantum team, before going to Oxford to get a PhD in quantum computing and quantum error correction. David used to lead the quantitative research team at JP Morgan. John is leading our software. He has some banking background. Alan used to lead the quantum AI product at Google. And Tarun is a physicist. He's an experimentalist, but he's working on AI with us. So why do we exist at Icosa? We think that quantum physics is at an inflection point, and we realize that quantum physics, maybe in the form of quantum computation, allows us to solve very difficult problems. One of those problems is discrete variable optimization, anything that involves yes or no decisions at a very large scale, thousands and thousands of those. And the reason we exist is to fill in this gap where how do we use these quantum resources to solve these kinds of problems. And these resources are often not accessible, and even if they're accessible, they're not tuned for specific problems that exist in the real practical world. So that's why we built this software toolkit that achieves two things. One is it achieves scale, so it solves up to 30 times larger problems than what's available today with regular methods. And also it tunes models, tunes the hyperparameters, such that they achieve something practical. For example, financial portfolio optimization, which I'll talk about in a bit, but also a very cool application in AI, which I'll also talk about. But what do I mean by quantum? So this is called the Quantum Summit. So quantum computers themselves have the potential to solve discrete optimization problems more effectively than classical methods. But they don't scale currently with the problems that we have today at the practical level. So we exist to fill in that gap where we use algorithms that are quantum-based, quantum physics-based, that can run on quantum computers, but also can run on classical GPUs, CPUs, that already today have an advantage. And also we use specific chips, for example, application-specific integrated circuits, ASICs, just built to solve discrete optimization problems. And hopefully, also all of our code base can run on quantum computers, can run on QuEra, but hopefully in the very near future, we will be able to run on quantum computers at thousands of variable scale. So we deployed in finance already. We take financial data in real time, feed it through these quantum-inspired resources, and reach an optimal solution. This is really fast, 2 to 3 minutes. But we tune our models 24/7, so there's some computation going on all the time. this is really exciting. We just took everything we built for finance and applied it to induce human-like reasoning in LLMs. Of course, it's a hyped-up area right now, but we saw the potential where we can actually improve large language models where they hallucinate. So we reduce hallucinations right now and are partnering with some industry giants to solve this problem. There's a lot of value to be created for quantum. We have a threefold approach where you can try our freemium model where you can solve toy problems, or I mean 1,000 variables is still big enough, but if you want to use the cloud product, then it's going to be up to 100,000 discrete variables, and these are fully connected problems. So for the physicists out there, these are all-to-all connected Ising models where you can sample the ground states of these Ising Hamiltonians. And our enterprise, we're already post-running with enterprise, so if you're a corporation looking to solve these problems, please reach out to us. We just work in the finance and AI space currently. We, for example, tripled the return of a hedge fund we work with. They were quite happy with that. We published a white paper with NEC Corporation where we optimized 25,000 stocks at once. These are fully connected, so all of the stocks had relationships with each other. You can see the paper in our website. And actually, all the customers we work with invested in the company for equity. And yeah, please be on the lookout for our LLM enhancer soon to come out. We raised our pre-seed. Some investors include founder of Fancy, ex-head of Morgan Stanley quantitative trading team. As I said, our customers from the finance world. And we were supported by UChicago's Duality program, but also Creative Distraction Lab in Toronto. And we will announce our seed round next year. That's us. Thank you.
Great. Thanks, Mert. Our second panelist is Yoann Jestin. And again, I will let him introduce himself and tell you what he's working on before we get into the questions to the whole panel.
So yeah, thank you very much, Alex. So my name is Yoann Jestin. I am the CEO and co-founder of QuEra Photonics. It's a university spin-off based in Montreal, Canada. And we are basically building hardware for the generation and manipulation of quantum photonic signals with a primary focus on entanglement distribution and quantum networking for telecommunication. So just to give you a little bit of a context, this is the worldwide map of the quantum networking activities and all the test beds that are now deployed all around the world. So you can see there are a lot of activities in Europe because they were kind of a precursor on testing quantum key distribution, but it's growing a lot also in North America, and there's a lot of initiatives mostly for entanglement distribution. So quantum networks can be seen as the glue of the quantum ecosystem, and can be used, of course, for securing the communications, but also for other types of applications like distributed quantum computing and distributed quantum sensing. So in order to do that, in order to distribute quantum resources, there are some essential requirements that we need to focus on, and these are the universality. So we don't want to build hardware and not being able to implement them, for example, in the classical communication system that we are using every day to communicate. So this is something very important. The scalability and energy efficiency is also very important. So if you want to deploy your hardware all around the world, you have to be scalable. And also you have to adapt the classical techniques, for example, for signal processing. The classical ones, you have to adapt that in the quantum domain, for example, do multi-channel information processing. So that's really what we are trying to do at QuEra Photonics. So we are building sources of entangled photons using integrated optics. Those entangled photons are distributed over an optical frequency comb. It is ITU compatible. It works at room temperature. And we are really trying to push for time and the frequency degrees of freedom. And we are also building a quantum signal stabilizer. So it's basically a fiber-based interferometer. Why it's fiber-based? Because we don't want to lose our photons going from the fiber to an integrated chip and then after going to another fiber, so everything stays in fiber. And it's a very stable way to do temporal encoding and also stabilization of quantum channels into the network. So for now, we have partnerships with some different US national labs and industry. So we started with the US Air Force a few years ago. We had a collaboration with the Fermi Labs also one year and a half ago. And now we moved away, and then we have some project pilots with the National Research Council of Canada. We also recently got some research and development contract with a big corporation that is working on quantum networking, and then we're going to ship one of our devices at the end of Q2 2024. And the next step is really to have our hardware that's going to be deployed into quantum testbeds. So here I mentioned, for example, the Kirk quantum testbed that is going to be based in Montreal. And we're going to have a lot of fibers, and we're going to be able to deploy our hardware in this testbed, see how the entanglement distribution is working, and then invite potential people to find some applications that can go beyond QKD application, for example, multi-party computing application and things like that. So yeah, thank you for your attention. If you want to discuss with me later, please feel free to contact me. We are part of the Duality program this year. We're also an alumni of the Creative Destruction Lab. And yeah, that's it for me.
Thank you. Next on our panel, we have Lisa Rooth. She is the COO and also a co-founder of SCALINQ. And she will tell you all about what they are doing and their trajectory.
Yes. So hi, everyone. My name is Lisa Rooth. Like you mentioned, COO and co-founder of SCALINQ. And what we do is that we want to accelerate quantum computing research. So I think we're all very excited about the different kind of potentials of this technology. And there are, of course, many challenges that we need to overcome. And the one I'll talk to today is the one that we're addressing, which is the major hardware bottlenecks in these systems today. So at SCALINQ, we realized that there's a big piece missing in scaling up quantum computers, but also with the systems that we have today, and that's in the cryogenic hardware. The hardware connecting to the processor started to becoming a bottleneck, especially when scaling up to more number of qubits, as we've seen around the globe. There was a lack of solutions on the market, and a lot of people had in-house solutions, homemade, that came with quite poor performance, but were also quite prone to errors, especially at scale. So this was the issue we set out to solve. And today we have a growing portfolio of high-density cryogenic hardware, and I'll just briefly walk you through them today. And these are readily available and used by companies, universities, and national labs around the globe. So our first solution was Linker, which is a packaging solution or sample holder directed towards spin and superconducting qubits. It's been validated at Chalmers Technology of University with a 25-qubit device with the data you see here. It's quite scalable, up to 300 lines through our high-density connectors. And it also allows you to host multiple devices at once. So you can actually measure several chips in one cooldown, really speeding up the development time. This patented solution also allows for rapid sample exchange. So regardless of how many connectors you have, you can actually switch your sample in just a minute or two. And it's also fully non-magnetic. And this summer, we also released our low-pass infrared blocking filter, provided in an inline form factor, fully non-magnetic again, with a very high-density design. It's offered in single units, like the one you can see on your left, but also in blocks of 24 that you can directly plug into your high-density wiring fridge. This is offered in 10 gigahertz cutoff frequency, but we're also expanding that. And we also have Brick, which is an adaptable breakout box, allowing you to connect your high-density wiring fridge to whatever connector or components that you have today. And that's the current portfolio. Of course, we are developing a lot more that I cannot share too much about, but we are doing this together with the whole ecosystem. We're collaborating with industry and academia, from the people working on the qubits to the room temp electronics, really ensuring that the development we're doing is in line with the technology roadmaps of our customers and partners. And we see that we are filling a clear gap in the industry, working close on the mixing chamber region. The team behind the SCALINQ is interdisciplinary, from low-temp physics to mechanical engineering, electrical engineering, and of course quantum physics as well. We also have advisors from various fields. Many of you, I'm sure, know Peter Leek from Oxford, maybe also Bart Smulders from TU Eindhoven. And our vision is to help the field of quantum computing by developing state-of-the-art cryogenic hardware and bring solutions to where it's most needed today rather than tomorrow. And if any of this was interested to you guys, then feel free to catch me in the break or reach out to me by this contact information. Thank you.
Thank you, Lisa. And the last panelist we have today is Sean Sullivan. He is the Chief Technology Officer and also co-founder at memQ. I hope I'm pronouncing that correctly.
memQ, yeah, exactly. Yeah, thanks. So as Alex mentioned, I'm Sean Sullivan, co-founder and CTO of memQ, which is a spin-out from UChicago Argonne Research here in Chicago, namely focused on creating quantum network hardware. So basically, we've heard a bit today about quantum networks and generating entanglement. And there's different ways you can think about quantum networks, either from the scale of a single chip, where you have multiple qubits communicating over to rack-mountable hardware in quantum data centers, all the way up to sort of global linking networks. And so what we're focused on is building the hardware. Basically, we're building a quantum system on a chip to manage entanglement across various network scales. And we're doing this with optical photons in the telecom C-band, working with rare earth ions integrated with silicon photonics. So our vision is this sort of quantum repeater chip where you can generate, store, and manage entanglement that plugs into optical fiber networks with low loss. So we've been at this for about a year, so we're quite new. We were in cohort 2 of Duality. We're currently embedded in the Chain Reaction Innovations Program at Argonne, which is a DOE led program. We have some recent results, some collaborations, papers with Argonne in terms of deterministic placement of our rare earth ions on quantum photonic devices. We've been working a lot on also this low loss packaging. I think this is crucial for quantum photonics in general. And we've completed our team now after raising our seed round earlier this year. We're now at 6 full-time people, and now we're taping out chips, moving from in-house chip development in the National Lab Clean Room to commercial foundries. So yeah, we've completed our team. We have a really excellent team. I'm really proud of the team that we've built in terms of we've got a large range of deep expertise from quantum photonics, silicon photonics, spin physics, quantum memories, and yeah, we're very, very grateful to the Chicago community here and our investors and partners. But yeah, find one of us in a memQ t-shirt if you'd like to chat more about our technology. There's a few of us here today. So, great.
Thank you, Sean. So now you have a sense of who's in front of you. 2 commonalities between all of our panelists, all of them founders and executive officers of startups in the quantum space, and all of them participants in the Duality program here at Chicago. So I think it's a great thing that brings everyone together. I, of course, have many questions. But one thing that I notice is, before going into those questions, I think that this panel represents something very important about the state of the quantum industry, in that we have startups that are covering everything from hardware components to application development, to networking. In our case at QuEra, also full quantum computing systems. And I think that it's very good to see that the entire industry is growing and diversifying and finding the right niche for all of these companies. And that actually leads me to my first question. And I would like to hear, in order of how you're sitting, what role do you see startups playing in the quantum ecosystem? I mean, earlier today we got to hear from Dr. Krishna, the point of view of one of the largest corporations in the world. But I'm interested to hear from you, where do you see startups playing a role in our industry?
Is it me?
Yeah, let's start with you.
I think, so I guess in our domain, in deep tech, most startups have a foundational academic and scientific element in them. And it's sometimes hard to differentiate ourselves from academical researchers. So what's our role then, right? We sometimes publish papers. We try to push the scientific frontier. I guess our job as startups is to bring in economical value. How do we turn that research into, I guess, again, economical value? So that is going to be my short answer.
From my point of view, I think that the quantum market is driven by big corporations, like, for example, IBM for the quantum computers. But now there are also players like Cisco, AWS that are in the networking space. And I think the value that we can bring to them is mostly on specific aspects. For example, how you're going to interact with the device that I can build, for example. And it might be that the technology that you are developing match very well with what those companies are building, let's say on a bigger vision. So you might have something small that fits very well into their big ecosystem. So that's the value that we can bring to them. And then from that also, I think we can learn and grow and develop in order to work all together in order to make the ecosystem grow. And yeah.
Great.
Yeah, I agree with you guys. And I also think it's such an important tool to get research result out to other players. But also just the speed in which the development can happen, even though it's a very niche or specific area, that we're really contributing with development that we're maybe not seeing, or that's accessible at least to the whole ecosystem from the bigger companies.
Yeah, I mean, I think in general, right, academic research and even research at larger corporations can be a bit slower paced. So I think the value that startups can really provide is this sort of move fast and break shit kind of mentality, like where you can really efficiently and quickly utilize resources effectively. I think that's where I see a lot of the value that startups can play.
I agree. I think that this point about being agile and bringing the new developments quickly to market is a very important role for all of us at startups to be playing. But that leads me to, as startups, there's some credibility that you need to build, and evidently all of you have done very well through your companies. Based on your slides, all of the partnerships and customers that you have. How do you go about creating that credibility with your customers and developing those partnerships? Maybe we can start from the other end, just to switch things up.
Yeah, I mean, I think it's all about leveraging the network that you're working with. So you obviously partner in deep tech, as mentioned. You're working very closely with a lot of researchers and scientists, and so you still need to do good science, both in collaboration with them and on your own. And you need to be able to share these results and like with the community, get the community excited. So I think it is to build that sort of credibility. You have to show that you're still doing good science and good research and things like this, like so that people can trust you. Yeah.
Absolutely. I think for us, it was also an important aspect to have the university with us. So we're spun out from Chalmers University of Technology in Gothenburg, Sweden. And they've been using our solutions for, I think it's 2 years now. And they were able to share their results and why they were so happy with it. And that, of course, provided a lot of trust for our other early customers.
Yeah, I agree also that I think research papers, for example, most of the startups that are in the quantum space are coming from universities. So research papers that have been well written, also it can demonstrate good credibility. And then increasing your network and then talking to people and then telling them, okay, do you want to try this? That's, for example, one of the things that we did with Fermilab. We sent them one device, and then we figured out that UPS was almost playing soccer with the box that we had. So half of the thing inside the box was broken, but we learned a lot from that. And now we understand that, okay, this component has to be like this, because if it moves too much, this is going to be broken. So this is the kind of thing that you learn, and then you build credibility on that with the customers, and then you talk to people, and those people are going to talk to other ones, and then they say, okay, this one was doing something that is good, so maybe you can talk to him, and so yeah.
Yeah, when your existing customers talk on your behalf, that actually helps quite a bit. And also, well, how do you get your first customers? Having a great team with relevant experience in your area also helps. But in terms of scientifically convincing people to either pay for your product or invest in your company, I think robust benchmarking techniques help a lot. So quantitative results for finance, there are many. So in terms of artificial intelligence, this is also a newly developing area, and not AI, but LLMs. There's now new research in just benchmarking large language model performances.
So talking with customers and having proof points is what I hear in general. And I agree. I think that is, from my experience, it's exactly the same. It's developing those relationships over time and having little by little those proof points that show people that what you have is real. And on that note, one of the things that I think you hear about often is about the hype of quantum computing. And I'm interested to hear from your experience, how do you navigate this, this space between hope and hype in quantum computing when you talk with potential customers, when you talk with investors, when you talk even with your friends? Would you like to start, Mert?
Yeah, I mean, I guess we're in a special place because we don't actively try to sell quantum computing time to our customers, which is a very, very difficult thing to do. But as a researcher, if you look at history of science, there's always breakthroughs that actually are not linear. And we are seeing some, again, going back to quantitative results, that we are seeing progression in terms of quantum computing benchmarks since the industry started that are going linearly in terms of hardware, but also we see these jumps, big jumps, both on hardware side and both on algorithm side. So if you just point those to people and use examples from history, like classical computing, then I think it is easier to share the hope that quantum computing is not just hype, it will get there someday.
And I guess it's not just computing, right? It's quantum networking, it's quantum sensing, it's all of the quantum technologies that we're working on.
So yeah, there's a little bit less of hype in the quantum networking area, but I think it's growing. But one of the interesting things we saw in the quantum computing space is that on one side, there were people that were saying, okay, quantum computers, they're going to be available in the next 10, maybe 15 years. And then on the other side, there are quantum companies that are saying, oh, we are already using quantum computers. We are already solving problems. So you're kind of in a dual position, you know, so you don't know exactly where you are. But I think it's important to show that, for example, with quantum computer, but it's the same also with quantum networking, that you can do something. Even if it's not yet optimized, once it's going to be optimized, it's going to be better than the classical solution that we have. But you have to be trained for that. You have to understand how it works. And it's not when the quantum computer is going to be able to crack all the encryption that we have that you're going to say, okay, so now let's look into quantum networking and see what we can do with that to improve the security. So let's play with that. Let's show the things that we can do. And even if classical solutions are better for now, it's still important to have people understand what it does and what we can do with it.
Yeah, I agree. And I think we have to be a little bit careful with how we present what we think will happen in the future. I think over-promising won't help the community at all. But we also need to be able to communicate and explain what the promise is so that people really understand it in a realistic fashion. And I think sometimes we startups have a tendency to say what the investors want to hear rather than what might actually be the scenario we believe in. So I think it's a balance of being able to showcase the potential future, but without hyping it up. Yeah.
Yeah, I mean, totally agree with it's really important to manage expectations and set sort of boundary conditions for what you think is reasonably achievable, but also like sell a vision that that would really drive things forward, that you think is get people excited. So it's a tough balance, yeah.
And if I can just add something on that, I remember someone telling once in a Zoom conference, was saying we have to stop to talk about quantum. We have to say what it can do, but stop mentioning that it is quantum, because this is something that we're going to do. And I think maybe if you look back for the semiconductor industry, you are not saying, okay, semiconductors can do this or that. You're going to say, okay, we have this computer that works. You don't have to explain the physics inside your computer. It's semiconductor, but yeah. So we have to do the same with quantum, I think, in order to be able to show people what it can do without having this problem of understanding what is quantum.
Focusing on results, right? We're back to how you build that credibility with your customers. So I agree. And Lisa, you mentioned something that I think is very interesting about how sometimes there's a tendency to gear the message towards what investors want to hear. There's a lot of pressure for startups to be funded, to find the right investments. So I would be very curious to hear how your companies have approached investment, what kinds of investors you have sought out, and what have you learned from them and about them. Maybe we could start with Sean on that end of the panel.
Yeah.
I saw you smirking, so.
No, well, I was actually just smiling at one of our investors in the audience.
Off the record, even though it's being broadcast.
Exactly. No, we're very fortunate to have. I think it's hard to approach, like this concept of quantum has a lot of mysticism around it. So I think it's hard to find like a good match sometimes when you're talking with investors. But we're very fortunate that the investors that we've worked with have a deep expertise in quantum physics, backgrounds. So the technology validation, all of that is a bit more, I think, intense in that case than maybe if you're working with other investors. But I think it is it's important to educate, as best you can, like realistically what quantum is, and in not a very mystical way when you're talking with investors like non-specialists. Yeah.
And I think maybe our company is the odd one out here because we're fortunate enough to not have needed an investment. So we've grown organically together with our customers and partners.
Yeah, we don't have investors as well, but I happen to talk to some of them. But I think what is important to show them is where you're going to be in the next 5 or 10 years, and how make your vision, what makes your vision realistic also. So, for example, do you have partnerships, like we were talking just before, who you are working with, and how you think those numbers that you are showing me, that you're going to build a multi-million company in the next 5 years, how credible it is. So I think this is the most important thing when you talk to investors.
Mm-hmm. Yeah, for us, and I guess we realized this a bit later on, is that investors really need to understand your problem, the problem you're solving. It's not just investors, like anyone you're speaking to, like it could be your grandma or like your friend. Like they really need to grasp what you're trying to achieve. Although it might be really scientific, we tried really hard to translate that to be understandable. But the best investor meetings we had was always when they understood the problem. In fact, the easiest pitch I ever did was, as I mentioned during our slides, one of our investors used to lead the Morgan Stanley quantitative trading team, and it was really fast. He just, so yeah, we needed discrete optimization in our field. This was a huge bottleneck for us when I was there. I want to invest, and it was the fastest investment I ever got. So, but that's like cheating because he already knew about the problem, right? So I think the most difficult thing is to translate that science into a graspable problem.
I guess that's not cheating. That's just having a good product.
I guess. Yeah.
I want to pivot into a slightly different area, because earlier today we also heard about how, it was in the context of quantum computing, but I would extend it to quantum technologies. There may be one of the few things out there that are harder than rocket science. That was the quote. And we also heard a lot about the importance of systems engineering and systems thinking. So it's really bringing in very different perspectives now into what we're building. And I am very curious about how you attract, how you hire, how you retain talent, and especially for the people that you're bringing into the company that may not be quantum fluent, and how much training you need to do. Let's start with you, Mert.
Yeah, I mean, in terms of finding the right people, programs like Duality helped a lot because we're in an academic environment. We're in, I guess, UChicago campus, so we're hiring, by the way, so if there are any students. But in terms of retaining the amazing talent we have, I think it's just that what we're building is that everyone is going to benefit from it, both like financially, but also like in a sense of meaning, because I mean we're not just like okay, maybe this is a bad example, but we're not building a commercial app just to make money, right? We are actually building something that pushes the computational limits of humanity. And when you word it like that, people are interested. So if they actually have a belief in your value proposition in terms of meaning, what you're trying to build and what you're trying to achieve, your team members are going to be with you forever, hopefully. I mean, but, yeah.
Yeah, I think it's difficult for everyone in the quantum space to find good talent. But one of the things that we are looking for when we are hiring is someone that can adapt. I'm not necessarily looking for someone that has a PhD in quantum physics, but it's more someone that is going to be able maybe to learn, to understand, and maybe with a master student, you're going to be able to do more things than with someone that has a PhD in quantum physics. I want to maybe just only do that. with your master, you're going to be able to work on electronics, on software programming and things like this. And it's really trying to learn and to adapt, because especially in the startup world, you are changing, pivoting all the time. So one day there is something, the other day there is something else. And then to keep them, it's really trying to show them that what you are doing is important. You're not doing that just for the money, but because it makes a difference, it makes something. And then super proud of having something shipped to a potential customer, and then say, okay, we did that, and then we put the stamp on that, and then that's good. We did it all together with the team. So yeah, make them feel also really part of the team, of the ecosystem, that they did that. It's not the CEO or the CTO that are doing that. It's mostly them that are doing the work.
Yeah, I can just agree with both of you. I think communicating where you're going so that people get excited about the vision is crucial, regardless of from what field the person is coming in. But like you say, what brings people to startups is sort of this different world of a very rapid environment where you get to be a part of a journey and not just be one out of many, and really, really make a difference and make an impact every day, every hour. And I think that's what people really are looking for when they come to us.
Yeah, I think in general, both for the training purpose of like even people who don't necessarily have a quantum background but adapting to some of the problems that you're working on, but also in terms of retaining folks, it's good to look for people who are both curious and creative, because if they're intrinsically curious, they're going to want to understand this new area and problem solve, and they're going to want to work on an interesting problem. And that's, we presented, this is a very interesting, difficult problem. If they're curious and creative, they're going to be motivated to keep working at it. So, yeah.
I especially agree with that. The difficult problems. My experience is that the people that want to be at a startup are those that are attracted by big problems, and solving small things is not, everyone has to do everything at different times, but that is really what gets people motivated to solve those challenging problems. And I think that Mert, what you were saying in the previous question about how do we frame this, right? It's not just we're doing this small thing, but we're really trying to revolutionize how we can even think about technology. I think that's the thing that really keeps the whole organization moving forward with enough momentum. I have, of course, more questions that I would love to ask, but I do want to give a chance to people in the audience to ask any questions that they may have. And I see a question right over there. So I believe the question was, how do you navigate the ever tricky situation of data confidentiality and IP between you and your customers and partners?
Yeah, so there are NDAs, but for us, like when we talk to customers, even before the legal stuff happens, we are very clear that we will keep all the IP that we built in-house. And the reason we work with two industries, finance and AI, is just for this particular reason. Because other industries, for example, like more consulting-based industries where you go to big corporation and they have, let's say, a manufacturing problem and they want you to solve a discrete optimization problem for them. It's a few month contract and they do pay you well, but they usually keep the IP in-house. So we for those, I cannot speak, but for example, finance, data confidentiality is very, very important. Some of our potential customers, they don't want to hear the word cloud at all. They don't want to submit any of their data, their signals, their alpha, their secrets to this cloud, right? So for those, we have a particular arrangement where we build what they need on-prem, so it fits their hardware quite well. For AI, it's a new area. It seems that data is more available to the public. in terms of like user data. But IP, that's something that we're investigating, so that is a great question.
Anyone else?
I mean, we do have legal structures in place to just highlight to everyone, you know, this is the IP that we're developing that will belong to us and vice versa. And I think it's just clear to set the expectations. And if it's a good partner, then it's not that tricky, I would say.
I agree. And I think, at least from my experience, it builds up over time, right? You might start with, especially for data that is sensitive, you might start with something that is a synthetic data set that resembles the types of qualities that you'll be developing solutions for. And it's only over time that the relationship is built that you get to actually share the more confidential information and the sensitive information. Yes, we have, oh wait, sorry, I think we have, was that a question in the back? No, if not, then we have a question here up front. I believe this is coming from. Oh, it's a literal race to the bottom.
This is a question from our virtual audience for SCALINQ. There's a similar wiring bottleneck in trapped ion quantum hardware. Are there any SCALINQ products for the ion trap platform, or are the products compatible across platforms?
So we're directed towards the spin and superconducting community. So that's out of my ballpark.
Any other questions in the audience? Yeah.
How do you see the role of government?
How do you see the role of government?
I mean, coming from a national lab, I think it's the role of government is pretty clear, pretty important. They kind of set some of the, let's say, boundary conditions for the space, like depending on the location where you're working. In the US, there are certain areas of research that are more favorable than others. And I'd say that a lot of that is kind of dictated, or not dictated, but directed by government agencies as well. So they're sort of helping set some of the direction. I think they also, you know, generally, as we heard this morning with NIST, there's this interest in you know, generating economic development here in the U.S. in particular, and other countries have similar efforts. So I think through grants or you know, collaborations, I think the government has a very important role to play in strengthening, bolstering a lot of the startup community in quantum.
Yeah, absolutely. Even just grants. I mean, again, differs between countries, but there's a lot of support that's being given in this field and to SMEs in particular, which is very good.
I think it's difficult to answer the question because the government has so many different facets to it, right? There's research grants, there's economic development programs to help develop the workforce. There's a lot of money that goes into developing the technology even within institutions within the government, as we heard this morning. And I think that as an end user, the government also has a big role to play, not to mention creating infrastructure so that we can all be here doing the things that we are doing. So at least in my mind, there's just too many different ways in which the government plays a role to really synthesize this into a simple answer.
I think also it's important that now that the ecosystem is growing, that governments are not putting too much restrictions also, for example, between countries. So not to stay isolated, just one country that doesn't want to collaborate with the other one because of this or that. So now it's pretty open, but we can see that I'm pretty sure in the future there's going to be some changes and because of regulations and things like this. So.
Yes, I see a question up here.
Hi. In terms of creating startups in an emerging tech field, how important is the role of accelerators and incubators such as the Duality Accelerator?
A lot. I mean, incubator means basically like, I think in biology, correct me if I'm wrong, it's that the organism cannot live on its own, so you incubate it so that it develops, right? It's too early to be alone in the world by itself without the sustainment. So duality for us basically did that. I mean, there are infinite number of resources that I can list from the Chicago ecosystem. We just talked about the role of the government, grants, right? We, for example, did the regional ICOR program here, worked with MBA students, got a small grant, got access to, more of motivation, not access, but motivation to talk to potential customers and survey them. But yeah, very, very important. Incubators are great. But the most important, I guess, part of incubators is like you get to shoulder with other founders, and they're going through similar problems as you are in the same time region. Not that you don't read the book of like Elon Musk 25 years ago, which is completely irrelevant to what you're building now. It's better to talk to Lisa, for example, right? And how we were talking today over lunch. It's very important, basically.
I think the accelerators are also here to make you become a real entrepreneur. Most of the deep tech startups are coming from academia. You have a really, really different mindset, and becoming an entrepreneur, trying to understand how you can pass your message, how you can adapt to customers, what you're going to say to a student, what you're going to say to an executive. What you say is going to be completely different. So you have to learn that. You have to simplify your message, and accelerators are great for that, I think.
There's one more question up here in front.
So if I could oversimplify faculty life as an academic, right? So people say publish or perish, and so the goal is to come up with some publication such that everyone can duplicate your research and it can be replicated by everyone. So you want to be really clear about that. And if I can oversimplify something that I don't know anything about, because I'm not in a company yet anyway, the goal is to make it so that no one else can do the particular thing that you can do. And so I just wonder if you could comment on the tension between sort of making the magic sauce available and keeping it secret.
Any thoughts?
I think also in academia, when you publish, I mean, if someone else is reading your paper, maybe he's not going to be able to find the secret sauce, because there is always something that maybe you don't want to show to everybody. But it depends on who is publishing. But yeah, it might be tricky for sure to make sure that nobody's going to replicate your thing. But that's where the trust also has to be built with your potential partners and things like this. So you say, okay, I give you this, but yeah, I'm kind of sure that you're not going to do exactly the same in your garage and then sell it to other people. So.
Yeah, I mean, I'd say the value of publishing as a company is to show that this technology can work, right? Like to the community that it is physically possible, and that this is, you know, exciting results or something if you can publish it. But I think the value then becomes, that's where IP starts to come into play, where you can protect it. Even if an academic researcher can reproduce it, they just can't sell it necessarily. So it's, you can have things that are reproducible by the academic community, but then you have this additional layer of protection that sort of protects the business.
Yeah, and I think it's a great question, but from our point of view, it's also about, you know, we want to save the time and resources for physicists. So we could make something and make it available for you to replicate, but the goal for us is to make it accessible, to get it to you in a quick time frame, and you don't have to spend hours of trying to figure these things out, because we're going to ship it to you very quickly anyway, so you don't have to, and focus on what your research is actually about, and let us solve the engineering challenges instead.
I think that's a great point. It's not always about doing something that others cannot do. It's about doing it in a way that makes their lives easier, right? And I think that oftentimes it's also not about being the only one that can do it, but being the first one always that does the next thing.
Yeah, I definitely agree with that idea versus execution, right? Which also I think happens in academics where who writes the paper first? There are ideas around and very smart people in the world, but who actually does publish first, I think it's not important in terms of science because then you can always publish more papers. But maybe like you guys came out of a Harvard lab. Am I allowed to ask you questions?
Oh, how the tables have turned. Sure.
So how was your journey in terms of like starting out of a Harvard lab, and then how do you navigate?
Yeah, I mean, I think it's an excellent point how we balance this, because there are trade-offs right now, especially with the industry being so early stage, where we have a lot to gain by working together, by building collaborations, by opening up a little bit what we're doing earlier, so that can accelerate others in a way that feeds back into a loop that is positive for the entire industry. Of course, there are things that just by virtue of doing it more often and having larger teams, the approach ends up being slightly different in the company rather than the university, as you mentioned, right? Like for us specifically, we had a lot of learnings from the research that we did at the university and that we continue to support and collaborate with. A lot of know-how that allowed us to build better systems faster, more reliably, and where we continue to see the benefits that we reap by working together with academics around the world to solve the really challenging and hard problems, but at the same time by focusing no longer on just the academic research, but really on customers and finding ways to address their problems, we're able to provide something that is valuable that up to recently was pretty much hidden behind a gate at a university. The kinds of capabilities that we offer now through the cloud are things that 2 years ago there were 5 people in the world that had access to, and now everyone can just go online and start working with it. And for us specifically, we see that as a huge accelerator for research and for scientific discovery. So I think that yes, it is a balance, but we're early on, and I think the balance still steers a little bit towards being open and collaborative. Great. Well, I'm going to ask everyone to thank our panelists once more.